guys, I'll be going over this question in lesson 4.7. And this question, Ben drops from a height of 100 meters, and he's attached to a bungee cord that's 40 meters long that applies an average force of 1,500 newtons. So the first question, how long will it take Ben to fall to a height of 60 meters? So at this point he falls 40 meters from the top, and at that point the bungee cord hasn't affected his acceleration yet. So we can use the equation displacement x equals 1/2 acceleration t squared. And since he has no initial velocity yet, we don't need to worry about the second half. So we know displacement is 40 meters. And acceleration and displacement are going the same direction. But so since he's going downwards, it would be negative, but since they're going the same direction, it doesn't really matter. And acceleration is negative 9.8 because of gravity, t squared. So if you solve that out, that should be, t should equal about 2.9 seconds. Part B, how long will it take Ben to reach the bottom of the drop? So that's past the 40 meters all the way to the bottom. And here we can use the equation velocity equals acceleration times time plus initial velocity. And to find the initial velocity, we have to find the velocity where Ben is just at the bottom of the 40 meters. And to find that, we can use what we know from the first question. And we know that his acceleration was 9.8. So it's negative 9.8 times the time that we found, which is 2.9. And that should be 28 meters per second. Negative 28 meters per second. And the acceleration here is going to be different from before because at this point the bungee cord is going to be applying 1,500 newtons of force. So we can use F equals ma for this. And our force net is 900 newtons. His mass is about 60 kilograms because the diagram tells us that force of gravity is 600 newtons times acceleration. So acceleration is about 15 meters per second squared. So this is an upwards acceleration, and his velocity is going downwards. So we know we can plug it into the equation that we have. So velocity equals 15 newtons per second times time per second squared times time plus negative 28. And then we also know that his end velocity is going to be 0 because at the bottom he'll stop momentarily before returning back up. So we know that the final velocity is 0, and all we have to solve for is t, and that should be t should equal about 1.9 seconds. So this is how long it will take him to go from 40 meters below to the end. So we have to add the original time, 2.9, and then that's about 4.8 seconds. So for part C, what will be the height above the ground when he reaches the bottom of the drop? So we can use the same equation we did for part 1. Displacement x equals 1/2 acceleration t squared plus, this time we actually need to use the initial velocity because we're going to be finding how far he drops from here to the bottom of the drop. So displacement x equals 1/2. Acceleration is what we found in part B, t will be the time that we found before we added the 2.9, so it'd be 1.9 squared plus the initial velocity, which is what we found here also. So negative 28 times t again. So displacement x would be displacement x should be negative 20.5 since he's going downwards. So we know he drops 40 meters initially, and we just add that to what we found, so 40 plus 20.5 is 60.5 meters.